More divisibility rules. And today we'll talk about 5, 10, 2, 4, and 8. That's a lot, but 5 and 10, because it's quite simple. If it's divisible by 5, well, let's start with 10. If it's divisible by 10, it'll end in 0. Alright, so that's fairly simple, right? We're done with that one. Ends in 0. Alright, if it's divisible by 5, right, that includes all the ones that end in 0, because 10 is 2 5s, and the ones that end in 5. So if it ends in 5 or 0, it's divisible by 5. And that takes care of 5s and 10s. Just look at the last digit. And there's the bell. Perfect transition. For 2s, 4s, and 8s, it's also quite simple. Right, we know that any number divisible by 2 basically is an even number. So if it ends, right, last digit in 2, 4, 6, 8, or 0, it is divisible by 2. So 586 is divisible by 2. Now, 4, basically, check and see if it's even. Right, or check and see if it's an even number. Right, last digit. That's all. Look at the last digit to determine if it's even. Now, 4, if it's divisible by 4, it's divisible by 2 twice. Right? In other words, if I divide it by 2, take half of it, and then see if it's still even. If I divide by 2 and find out that it's odd, then there is only 1 2, and it's only divisible by 2, not 4. If I divide by 2 and it's still even, that means there's another 2 in there, and so it's definitely divisible by 4. So I can just divide that by 2. Let's see. 2, 4, 1, 18 divided by 2 is 9. And then, okay, this one is not divisible by 4. This one is divisible only by 2. So you guessed it. For 8, I'll divide by 2. If it's still even, I'll divide by 2 again. If it's still even, then there's a third 2 in there, and it's divisible by 8. Alright, so you just have to keep track of how many 2's you can get out of a number. So let's try 588, since I know that I should get at least 2 2's out of there. So it is even, so it's divisible by 2. Now let's see if it's divisible by 4. 294. Oh, look, it is divisible by 4, because I got another 2 out of there. So 2, check. 4, check. Let's see if it's divisible by 8, or, this number. Well, let's see if there's another 2 in there. 1, 4, 8, 4. Oh, hey, there is another 2 in there. So now this one is also divisible by 8. Look at that. Alright, so that's checking for divisibility by 2, 4, and 8. There is another way to do 4s and 8s, especially if your number is big, and here is how it works. It's like this, but there's an even more interesting shortcut to it. So divisibility by 2 is simply if it's even. Divisibility by, which, let me include that here, because it forms a really neat pattern. Divisibility by 2. Okay. Right, all you need to look at is the last digit. Is the last digit even? Right, because that makes the whole number even. Last digit is divisible by 2. In other words, it's even. For numbers divisible by 4, all you have to do is look at the last 2 digits and ask, are those 2 digits divisible by 4? You don't even need to check the whole number. Are the last 2 digits divisible by 4? So if I look at the ones that we did just now, 586 and 588, right, I don't even need to divide the whole number. I can just check and see, are the last 2 digits divisible by 4? And that can be a little bit easier, right? 86 divided by 2 is 43. No. Or I could just go straight to 4 and say, well, 8 divided by, right, so I'll rewrite it. You don't have to, you can, the nice thing is you can just look at this and try. But, right, 8 divided by 4 is 2, but 6 divided by 4 is not going to be a whole number. In other words, I'll have a remainder. 88 divided by 4 is 22. And so 588 is divisible by 4, as we saw before, and 586 is not. Wow, cool. Let me give you the last rule, and then we'll talk about why this works. Divisibility by 8. Again, I don't have to check the whole number, so that's handy if you have big numbers. For divisibility by 8, I just need to see if the last 3 digits are divisible by 8. So what that means is if I had some really huge number, such as this, I wouldn't need to try to divide that, say I'm checking for 8. I don't need to divide that by 8, right, which you could. Right, even with all that I said over here, you can go ahead and try to divide it by 4 and 8, versus doing this, seeing how many times you could divide by 2. That is absolutely up to you. But whether you do 2s, 3, twice and see if it's even, or divide the whole thing by 8, you don't need to do all of those digits, you just need to do the last 3 for 8. And for 4, you just need to look at the last 2 digits. Well, why does that work? And this is kind of neat. Well, any large number, let's look at it this way. If some number is divisible by 4, so 4 times, that means that 4 times an integer gives me my number. So 4 times some integer is equal to my number. And this is a large number, right? So, this is only helpful looking at the last 2 digits if my number is 3 digits or more. Well, that means I have at least 100, right? And my number, if it's 3 digits, it's going to be at least 100. Well, 100 happens to be 4 times 25. 200 is 8 times 25. Or, in other words, it's 4 times 25 times 2. 300, 4 times 25 times 3. Any 100, any multiple of 100, 5,400, 100 hundreds, or 10,000, is going to be 4 times 25, because that's 100, times some multiple. Right, so if I have 16 hundreds, that's 16 times 4 times 25. Any multiple of 100 is going to be evenly divisible by 4. So I don't need to worry about what's past those last 2 digits. All I need to worry about is, okay, is the rest of my number divisible by 4? Right, so this number is divisible by 4, because my 100 hundreds is divisible by 4, and then so is my 4. But this number is not divisible by 4. I've got 100 hundreds, which 4 goes into evenly, but then I've got another 4, and then I have 2 left over. So all I have to do is look at, that's why I only need to look at the last 2 digits. It's a similar reason for 8s. Only here, right, 8 doesn't go into 100 evenly, but 8 goes into 1,000 evenly. 8 times 125 is 1,000. So any multiple of 1,000, 5,000, 26,000 is a multiple of, right, 26,000 would be 26 times 8 times 125, because this is 1,000. Any 1,000 is going to be evenly divisible by 8. So all I have to do, because I know that my thousands are divisible by 8, I just have to check those last 3 digits to see if they are also evenly divisible by 8. Because then my whole number will be evenly divisible by 8. So, that's checking for divisibility by 5 and 10, 2, 4, and 8.